Good day to all of you. Welcome to EC Physics. Learn physics as easy as 1, 2, 3. Through this video, we are going to discuss about equipotential surfaces and their properties, which is meant for students of class 12. Through our previous videos, we have already discussed about electric potential, potential due to point charges, distribution of charges, and potential due to electric dipole. Hope you all have watched those videos. If not, please do visit my channel and watch the videos on electric potential. Equipotential surfaces, the word itself has got the meaning. They are nothing but the surface at which the potential due to charge distribution is the same. That is, when you take an equipotential surface, at every point on that surface, potential will be the same. We have studied different types of charge distribution, right? Let me take the charge distribution of a uniform electric field. We already studied it can be represented by using equidistant parallel straight lines, right? If you draw the planes cutting these lines, every point on the plane will be having equal potential, same potential value. I have drawn here three equipotential surfaces, V1, V2 and V3. If you take any point on the plane containing V1, potential is going to be the same. They are representing plane equipotential surface. Depending on the nature of the charges, shape of potential equipotential surface also will be different. Let me show you another example. If you have an isolated positive charge, this represents electric field around an isolated positive charge. This we have already discussed and studied, right? If you draw a surface connecting equal distance from the positive charge, electric potential will be same at each point, right? So when you connect those lines, you will get circular paths, isn't it so? So circular equipotential surfaces or spherical equipotential surfaces will be there for an isolated charge. Now let's discuss what are the properties of equipotential surfaces. We have already studied that the potential difference equation is, it is work done in unit charge, right? So VB minus VA, potential difference will be equal to WAB by Q0. Equipotential surface means if you consider 2 points A and B, the potential at each point is going to be same, which means VB will be equal to VA. If VB is equal to VA, VB minus VA will become 0, right? Which implies work done will be 0. So the first property of equipotential surface is, in order to move a test charge from one point to another on an equipotential surface, we don't have to perform any work. Work required to move a test charge from one point to another on an equipotential surface will always be 0. To look into the second property, as we know that since no work is done on an equipotential surface, we studied one equation for work done connecting electric field. What is that? Yes, W equal to negative line integral of electric field. That is WAB equal to minus integral A dot B E dot DL. Right? E dot dl means it is nothing but E dl cos theta, right? Dot product of two vectors can be written as A, B cos theta. So here it will be E dl cos theta. E dl cos theta is 0 because we studied that no work is required. So E dl cos theta will be 0, which implies cos theta equal to 0. For which value of theta cos will be 0? Yes, it's for 90 degree, right? So which means theta will be 90. That is, electric field will be always perpendicular to the line segment DL of the equipotential surface. That is the second property of equipotential surface. Electric field will be always perpendicular to the element DL. Third property is equipotential surfaces indicate regions of stronger or weaker electric fields. By seeing the equipotential surface, we can identify whether it has got strong electric field or it is representing weaker electric field. Electric field is defined as negative gradient of potential. We have already discussed and studied about it, right? That is, E will be equal to minus dV by dr, or dr is equal to minus dV by E. dV is a constant, right? Which means dr is proportional to 1 by E. So you can see that if dr is small, since they are inversely proportional, electric field will be strong. That is, separation of equipotential surfaces will be small for a stronger electric field, and vice versa. If the separation is bigger, then the electric field is going to be weaker in that region. Fourth point is no two equipotential surfaces can intersect each other. If they do so, then at the point of intersection, there will be two values of electric potentials, which is not practically possible. Electric potential should be of a unique value. Hope you all understood what are the properties of equipotential surfaces. To conclude, we can say that no work is done in moving a test charge from one point to another on an equipotential surface. Secondly, the electric field is always perpendicular to the element dl of the potential surface. Equipotential surfaces indicate regions of stronger or weaker electric fields. And lastly, no two equipotential surfaces ever intersect each other. Hope you all enjoyed watching and learning equipotential surfaces and their properties. Thank you for watching, and keep watching my channel to learn physics as easy as 1 to 3. Thank you once again. Have a wonderful day to all of you.